This video is about working with dilations in space and the coordinate plane. So remember that a dilation is an enlargement or reduction of a shape. When we do a dilation of an enlargement or a reduction, those shapes are going to keep similarity, which means the corresponding sides are going to be proportional to each other. So if we want to find a scale factor is the ratio that compares the new shape to the old shape. So another way to think about a scale factor is what number would I multiply the measurements in our first shape to get the measurements of the second shape. Our scale factor is always going to be a reciprocal of our similarity ratio. Remember, the similarity ratio then is the ratio of the sides. So let's look at scale factors with enlargements and reductions. So in an enlargement, we're going to go from a smaller shape to a larger shape. If we are going to do the scale factor here, we want a side from the new shape over a side from the old shape. So our new shape is going to be the one with the apostrophe, and the old shape is going to just be the letter. So the side from the new shape is 10, side from the old shape is 4. That are corresponding sides. That reduces to 5 over 2. When you do an enlargement, the scale factor is always going to be greater than 1. So let's look at the flip side of a reduction. So in a reduction for our scale factor, we're still going to do the new shape over the old shape. So our new shape has the apostrophe, the old shape does not. We have 9 over 15, which reduces to 3/5. If we are going to do a reduction, our scale factor is always going to be less than 1. So looking at our shapes, we can identify the scale factor that takes A to B. So we want to know what the scale factor is to go from A to figure B. So B is going to be our new shape, A is going to be our old shape, so we would have 3 over 8, and we can't reduce that at all. In number 2, to go from A to B, we went to a bigger shape, so we would have 6 over 4, and that reduces to 3 over 2. In number 3, again, we're going from A to B. We have 1/4 divided by 1, which reduces to 1/4. In number 4, we have a dilation of ABC to DEF. So if we look at the names of our triangles, ABC is our larger triangle, and we're going to DEF, which is the smaller triangle. So this is going to be a reduction. To get our scale factor, it's new shape over old shape, so we have 14 over 20, which reduces to 7/10. Now, the center of dilation, this is where all of our points meet up. So as we see, we have these dotted lines from A through D, B through E, and C through F. All of those points are meeting up here, which if this is our y-axis and our x-axis, that would be the origin. So our center of dilation is 0, 0. In number 5, we're going from DEF to ABC. So this time we're going from small to large. So this is an enlargement. Our scale factor is going to be the new shape over the old shape, which would be 9/5. Again, our center of dilation, if we follow those dotted lines, is going to the origin, which would be 0, 0. So now let's look at having a figure and using our scale factor to make a new shape. So in number 6, we have triangle GUM. So if we look at our coordinates, we have that G is at 0, 1, U is at 3, 1, and M is at 1, negative 2. So if we look at our equation up here, x to y changes to 3x to 3y. We're multiplying our coordinates by 3, which means our scale factor is 3 because we're going to create a bigger triangle. So for each coordinate, we're going to multiply by 3. So G prime would be 0, 3. U prime, we have 3, -1. We're going to multiply by 3, so we get 9, -3. And M, when we multiply, we get 3, -6. So I'm going to replot those points. So we have 0, 3, 9, -3, and 3, -6. I'm going to put my letters with each point and then connect them. So I've created my larger triangle, which should make sense that we got bigger because this was a scale factor of 3. Now, when I look at the other equation, we have x to y goes to 1/2 x to 1/2 y, which means our scale factor here is 1/2 because we are multiplying each coordinate by a half. So C is at -4, 2, A is at 2, 6, and T is at 8, 4. So when I multiply by a half, that's the same as dividing by 2. So C prime would be -2, 1. A would be 1, 3, and T would be 4, 2. So I go to 2, -1, that is C prime. 1, 3 is A prime, and 4, 2 is T prime. This time our shape got smaller because our scale factor is less than 1. In number 8, a dilation maps 5, 4 to 15, 12. What are the coordinates of the image of -2, 3 under the same dilation? So how did we get from the point 5, 4 to 15, 12? So if we're looking for how we dilate, we want our scale factor. So our scale factor here is what did we multiply 5 and 4 by to get to 15, 12? Well, all of these are multiplied by 3. So if I have my dew point of -2, 3, I want to multiply each of those by 3. So we would get -6, 9 as our new coordinate. In number 9, what is the image of the point 12, -4 after a dilation of 2, 5? So in this case, this is not a scale factor. This is going to be our similarity ratio. So if this is my similarity ratio, this is our old point, and this is our new point. So we have our old points. We need to do 2 proportions to solve for our coordinate. So we have the ratio of 2/5 is going to equal the x coordinate of 12 over x to find the new x coordinate. So when we cross multiply here, we get 2x equals 60, divide, and we get x is 30. We're going to do the same thing for the y coordinate. So 2/5 is equal to -4 over y. We get 2y equals -20, so y is -10. So our new coordinate then would be 30, -10. Now if we do our next point, we're going to look at the same thing. We have a dilation now of 3 to 2. So this is still our xy. This is still the similarity ratio of our old to our new. So if I have my ratio of 3/2, I'm going to set that equal to -12 over x. So when we cross multiply, 3x equals -24. So x is -8. And then we also have 3/2 equals 6/y. So when we cross multiply, 3y equals 12. So y is 4. So our new coordinate would be 8, -8, 4. So we're going to move past the constructing center of dilation because it's hard to do in a video. And we're going to go to looking at finding the center of dilation on a coordinate plane. So most of the time we said that they intersect at 0, 0 in our previous problems. But that's not always going to be the case for the center of dilation. So to find the point for the center of dilation, what we're going to do is we're going to pick 2 points from each triangle, and we're going to create lines of equations, and then we're going to set them equal to find our variable. So in the first one, I'm going to pick 2 points. So I'm going to first pick the top 2 points of each triangle. So in the smaller triangle, that point is 1, 3. And in the other triangle, that point is 3, 9. So we want to write the equation of a line. So what I'm going to do first is I'm going to find the slope. So in this case, our slope would be 9 minus 3 over 3 minus 1, which would get us 6 over 2, which reduces to 3. Then I'm going to pick one of the points. So I'm going to pick 3, 9 in this case. I'm going to write my equation in point slope form. So remember, point slope form is y minus y1 equals m times x minus x1. We're going to substitute our information in. So in this case, we get y minus 9 equals 3 times x minus 3. I'm going to distribute the 3, so y minus 9 equals 3x minus 9. If I combine the 9s together, I get y equals 3x. So I need a second equation, so I'm going to pick two other points. So the next 2 points I'm going to pick are these two. So these points are 1, 2, and 3, 6. So if I go to find the slope here, 6 minus 2 over 3 minus 1 gets us 4 over 2, which reduces to 2. Again, we're going to pick one of the points, so I'm going to pick 1, 2. I'm going to write the equation in point slope form. Y minus 2 equals 2 times x minus 1, and we're going to solve this to get y by itself. So I'm going to distribute the 2. Y minus 2 equals 2x minus 2. When we add 2 to both sides, we get y equals 2x. So if I have both of those equations, and they are both equal to y, we can take the 3x and the 2x and set them equal to solve for x. So if we take 3x and 2x, 3x equals 2x. I can subtract 2x from both sides, so x equals 0. Now that we know our x coordinate is 0, we can solve again for y. So we're going to take one of these equations. I'm going to take this whole equation. Y equals 2 times 0, so y is 0. So in this case, our center of dilation is still 0, 0. Now, this doesn't always happen, though, so let's look at another example. So in number 14, we have 2 points, and we can tell right away, if I start to draw dotted lines, they're not going to intersect at 0, 0, because the line is moving away from 0, 0. So we're going to start the problem the same way. We're going to pick 2 points, one from each triangle. So I'm going to pick this point and this point. So those coordinates are going to be 6, 6, and 10, negative 2. So the first step, we're going to find the slope. Negative 2 minus 6 over 10 minus 6 gets us negative 8 over 4, which reduces to negative 2. So I'm going to use one of the points. So in this case, let's use 6, 6. I'm going to write it in point slope form. Y minus 6 equals negative 2x plus 12. I'm going to distribute, so y minus 6, this should be minus 6. So when we distribute, y minus 6 equals 2x plus 12. When I add 6 to both sides, the constants don't cancel out. We have 18. So I'm going to move the 2y to the other side. So we have 2x to the other side. So we have 2x plus y equals 18. Then we're going to pick another point. So I'm going to pick these two. So those coordinates are 1, 6, and 9, negative 2. So when I do my slope here, I have negative 2 minus 6 over 9 minus 1, which gets us negative 8 over 8, which reduces to negative 1. So I'm going to use negative 1 and my first point right in point slope form. Y minus 6 equals negative 1 times x minus 1. We can distribute the negative 1. Y minus 6 equals negative 1x plus 1. When I add 6 to both sides, we have y equals negative x plus 7. So again, I'm going to get the x on the same side as the y. So we have x plus y equals 7. So this time we weren't as lucky with a problem, so we're going to have to do our full elimination. So when we do that, we have 2x plus y equals 18, x plus y equals 7. We need to multiply one of our equations to eliminate a variable. So I'm going to multiply this second equation by negative 2. 2x plus y equals 18. Negative 2x minus 2y equals negative 14. So as we add straight down, we get negative y equals 4. Divide by negative 1, so y is negative 4. Once we have that, we can solve for x by taking one of our original equations. So when I do that, I have x plus negative 4 equals 7. We can add negative 4 to both sides, so x is 11. So our center of dilation would be 11, negative 4.